Hello, good day viewers. You're welcome to my YouTube channel. This is Chemistry Hangout. It's been a while on this channel, and trust me, we are just looking for a way to make things better and to serve us better. So we are fully back. We are fully back. Chemistry Hangout is fully back, and we are loaded with a whole lot of things to actually give to us. Secondly, let me quickly thank my subscribers. You guys have been wonderful. You guys have been super wonderful. So I want to say thank you to my subscribers. Thank you for subscribing to this channel. Thank you for your comments. Thank you for sharing the channel to other people. I am very grateful. Indeed, you guys are wonderful. And I want to quickly say this. I have a kind of good news for people that are writing exams like JAM, like WAEC. I'll pass that info before the end of this video. So I want you to stay tuned. Stay tuned. We have a wonderful section. We're going to have a wonderful section today. And very important, if you are just watching this YouTube channel for the first time, please click on the subscribe button. You can share the video. You can comment on it. And I'm sure I've said that earlier. We are doing this to actually make us very comfortable with chemistry. We will not stop giving our best on this channel. We are going to give nothing but our best. So thank you once again and welcome you guys to this wonderful section. Before I actually give the good news that I have for people that are taking exam, I want to quickly answer a question by one of my subscribers. I checked some comments. Okay, so I saw one of my subscribers asking a question based on my last video. That was the bonding video. Please, if you have not watched that video, please do yourself a favor by watching that very particular video. I'm sure it will bless you tremendously. It will really bless you. So I will answer that question very fast by one of my subscribers, which will lead me to the topic for today. But I have said that if you really want me to actually tell you that good news, or if you want to be kept abreast of the news, the good news, if you are one of the people taking exams for this year, just endeavor to watch this YouTube video till the end. So after I've answered that subscriber questions, I'm going to tell you what I have for you for this year, and I'm sure it is going to really bless us. So let me quickly answer that question by one of my subscribers. You know, I did a video on bonding. So I made mention of polar covalent bonds, non-polar covalent bonds. You know, I was talking about polar and non-polar molecules in that video. So the person asked on the channel using the comment box, he asked me that how do we know if a molecule is polar, or how do we know if a molecule is non-polar? So the question he asked was, if you see a molecule or a compound, how do you know it is polar? If you see a molecule, how do you know it is non-polar? And I will answer that question with this very particular explanation and illustration. I'm sure after this, that question should be crystal clear to us. So let me quickly answer that question, why I explain vividly polar and non-polar molecules. Polar and non-polar molecules. I'll be answering that question, polar and non-polar molecules. That will lead me to this topic. Okay, I will do a simplified video on this. A simplified and a detailed video on this very particular topic, because I'm sure this very particular video will bless somebody out there too. So I'll take my time to explain, and please, I want to beseech us to watch this YouTube video to the end. Okay, I have polar and non-polar molecules. I'll simplify it. I've said that I'll start from the molecule. Then I'll move to the polar and the non-polar thing now. Now, when you talk about molecule, of course, from our rudiment chemistry, we know that when you talk about molecule, you are talking about the combination of atoms, okay? You can have atoms that are the same, or you can have atoms that are different. What am I trying to say? If I have oxygen, this is an atom, okay, plus another oxygen, you give me an oxygen molecule. Can you see that now? So oxygen atom plus oxygen atom, you give me oxygen molecule. And that is the combination of atoms will give me molecule. So when you combine atoms together, it gives you molecule. It is possible for you to have the same atom or for you to have different atoms. It's possible. You know, this one is the same atom forming molecule of an element because it is the same. We call it molecule of an element. But it's possible for me to have sodium plus chlorine like this to give me sodium chloride. Just trying to balance the equation. I'm just doing this just kind of review. So if you look at this one, the same atom giving you a compound, okay? And giving you an element, sorry. The same atom giving you a molecule. The same atom giving you a molecule. And if you look at the atom, they are the same. So this is molecule of an element. But you have different atoms. You have atom of sodium coming together with 2 atoms of chlorine to give you 2 molecules of sodium chloride. So this is molecule of a compound, this is molecule of an element. So summarily, if you talk about molecule, you are talking about the combination of atoms. Okay, let's now move to polar and non-polar. Now before I move to that, let me quickly teach us what we call polar covalent bond. Polar covalent bond and non-polar bond. Polar covalent bond and non-polar covalent bond. Let me start from this. Please pay attention, pay attention. I'm sure you will be blessed by this video. Okay, the polar covalent bond now. I have done a detailed video on bonding and I've explained covalent bond. If you have not watched that video, please do yourself a favor by watching that video. So when you say covalent bond, you are talking about sharing of what? Of electron. Now, how do you know if a molecule or a compound has a polar bond? So I'm explaining polar bond now. How do you know a molecule or a compound has polar bond? Let's look at this. If I have hydrogen, okay, if I have hydrogen like this, and I have chlorine, that's 2, that's 8, okay, that's 7. They will be lapping. I've done that in my last video. 7, that's 1, 2, 3, 4, 5, 6, and 7. If you look at these 2 electrons now, this 2 electron is being shared by these 2 atoms. Don't forget, this is hydrogen and this is what? Chlorine. Please, I'm explaining polar bond. Please pay maximum attention. Now, if you look at these 2 electrons, they are being shared by this very particular hydrogen and chlorine. But if you look at these 2 elements now, if you look at 2 elements, the electronegativity of chlorine is more than that of hydrogen. What do I mean by electronegativity? Chlorine likes to attract electron than hydrogen. So our polar bond will now come as a result of unequal sharing of electron. Electron being unequally shared. What do I mean by that? If you look at this chlorine, look at this hydrogen, they are sharing these 2. But in the real sense, because chlorine is more electronegative, it likes to collect electron than hydrogen. So the electron cloud, this very particular electron, is tending to move towards chlorine than hydrogen because chlorine will want to have all these 2 electrons to itself because of its electronegativity. Because of that, chlorine carries a partial negative sign while hydrogen carries a partial positive sign. Why is this like this? It is because the electronegativity of chlorine is more than that of hydrogen. So chlorine will be tending to pull the electron to itself. And by so doing, this chlorine carries a partial negative charge and this carries a partial positive charge. Now, because of the unequal sharing of electron between hydrogen and chlorine, and this carries a partial negative sign, this carries a partial positive sign, we say this very particular HCl has a polar bond. Polar from the word, it has partial negative, it has partial positive. So we can say HCl has a polar bond. So if you see any compound or any molecules having partial negative sign and partial positive sign, it means they have a polar bond. I hope you understand that. Let's look at another example. If I have nitrogen, let's take nitrogen as an example, or oxygen. Let me take oxygen as an example. So you know oxygen is 2,6 electronic configuration. So we have 2 and I have 6. 1, 2, 3, 4, 5, and 6. I have 2 here. And I have 6, 2. 1, 2, 3, 4, 5, and 6. Look at this. This very particular oxygen, they are sharing this electron. Don't forget this oxygen atom, this another oxygen atom, sharing this 4 electrons. The question is now this: will they carry a partial negative sign or will they carry a partial positive sign? Don't forget, the partial positive sign or partial negative sign comes as a result of unequal sharing of the electron. Chlorine tends to draw the electron to itself, and that's the reason why chlorine will have partial negative, partial positive. But looking at this, you have oxygen here, you have oxygen here. The electronegativity is the same, because the same oxygen you have here is the same oxygen you have here, which means that no one will be pulling the electron to themselves. They will be sharing it equally because they have the same element. Can you see that? Which means for this one, there will not be any negative, a partial positive sign. There will not be any partial negative sign. Can you see? No partial positive, no partial negative. Why? Because they will be sharing the electron equally. So when you share the electron equally, the kind of bond that you have here will be a non-polar bond. I hope you are following. It will be a non-polar bond. And why are you having a non-polar bond? Because they share the electron equally. When you share the electron equally, you have a non-polar bond. But when you share the electron unequally, that which means that one is pulling the electron down one, then you are pulling. So which means that all molecules that have the same atom, all molecules that have the same atom will have a non-polar bond. Can you see that? All molecules that have the same atom will be non-polar bond. E.g., nitrogen will be non-polar because you have the same element here. Oxygen is non-polar already. Chlorine will be non-polar. Chlorine gas will be non-polar. You get that now? So all molecules that are formed from the same atom, get that? They are formed from the same atom, we have non-polar bond because they tend to be sharing the electron in the same manner. So I hope you understand our polar bond and non-polar bond now. So if you have a polar bond, it means you have partial negative, partial positive because of unequal sharing of electron. And if you have a non-polar bond, it means you are sharing the electron in the same manner. I hope that is very clear. Now I want to go to our polar and non-polar molecule, which is the question the person asked. How do you know if a molecule is polar? How do you know if a molecule is non-polar? You can know that by two ways. How to determine? Number one, you look at the electronegativity difference. You look at the electronegativity difference. Okay? Look at the electronegativity difference. If the electronegativity difference is greater than 0.5, it means it is what? It is a polar molecule. I hope you are following. If the electronegativity difference is greater than 0.5, it means the molecule is polar. That's one of the ways. Which means if electronegativity differences is smaller than 0.5, it indicates non-polar molecules. That's first. You have two ways, very important. You cannot use only this to determine the polarity of a molecule. You cannot use this. And the second way by which you know is the what? Is the net dipole moment. Is the net dipole moment or movement. I hope you are following. So the first way I will know if a molecule is polar is that the electronegativity difference must be greater than 0.5. That's number one criteria. And number two criteria is the net dipole moment. What is the net dipole moment of that molecule? If I can know it, then I will know if the molecule is polar or not polar. Very, very important. You cannot use only one to determine the polarity of those molecules. You use the two to determine the polarity of those molecules. Let's take example number one. Let's see HCl. Is this molecule polar? That's the first example. Is this molecule polar? If you look at hydrogen, the electronegativity, the value for the electronegativity of hydrogen is around 2.2. Why for chlorine, the electronegativity for chlorine is around 3.16. Okay. Now, if you look at this, let's look at the electronegativity difference now. I have 3.16 minus 2.20. This will give me 6, okay? This will be 11, this will be 9 point, and this will be 0. So the electronegativity difference is 0.96. And if you agree with me, 0.96 is greater than 0.5, meaning it has passed the criteria 1. Criteria 1 passed. Are we together now? Criteria 1 passed. Criteria 2, let's look at the net dipole moment. If you look at HCl, we're going to have something like this, like the one I've demonstrated here, you know, the hydrogen and the chlorine. So what happens? The chlorine will be drawing the electron. which means it will be in this. It will be in this manner. The direction will be in this manner. And if the direction is in this manner, it means this thing will be having an attraction. Because the meaning of net dipole moment is that there must be a kind of attraction. I hope we are getting. There must be a kind of attraction. If the net dipole moment is 0, let's say for example you have one very particular charges neutralizing the other one, then we say it is 0. So the net dipole moment must not be 0. It must have a net dipole moment. There must be a kind of attraction around that very particular molecule. That's the meaning. There must be a kind of attraction around that very particular molecule. And that's the meaning of it as a net dipole moment. But if the net dipole moment is 0, meaning there is no any attraction in that very particular kind of molecule, which will make it to make the net dipole moment to be 0. I hope we are clear. So for this one now, there is a kind of attraction because the attraction will be tending towards this place because this one is electronegative, meaning this one has a dipole moment, which has passed the criteria 2. So which means is ACl polar? Yes, ACl is a polar molecule. ACl is a polar molecule. How and why? Number one, the electronegativity difference is greater than 0.5, which is 0.96. I hope you are clear, which is 0.96. Why? It has a net dipole moment because the attraction will be tending towards this very particular place. There is a kind of attraction there, which means it has a net dipole moment. Criteria number 2 passed. I hope you are clear. Criteria number 2 passed, which means ACl is what? Is a polar molecule. Which means that for you to be polar, the electronegativity difference must be greater than 0.5 and you must have a net dipole moment. I hope we are clear. Okay, let's see another molecule. Let's see another molecule, which is CO2. Let's see this molecule. Let's see this molecule, CO2. If you agree with me, for CO2, if you have not actually watched that very particular video on bonding, please try and watch it. For CO2, the bonding will look like this. Okay? I hope you are following. The bonding will look like this. And before we even do that, what's the electronegativity difference for CO2? Because we have said that the electronegativity difference. So for carbon, the electronegativity value is around 2.55, okay? And for oxygen, the electronegativity is around 3.44. So let's subtract. We have 3.44 minus 2.55. I hope you are following. Here gives us 9. I hope you are following. This one, 3, here will be giving us 8. Okay? Then we have 0.89. Can you see that now? We have 0.89, which is greater. Is greater. Are we together now? Is greater than the 0.5, meaning it has passed criteria 1. It has passed criteria 1. And if you look at it, in this kind of bond, oxygen, we have partial negative, if you remember. Oxygen, we have partial negative because oxygen is more electronegative than carbon. So this one we have partial positive. I hope you are following. Oxygen, we have partial negative, and carbon, we are partially positive because oxygen is more electronegative than what? Than carbon. To be drawing the electron towards itself. It has passed criteria 1. The electronegativity difference is what? Is greater than the 0.5, which is 0.89. Okay, and if you look at this is indicating that CO2 has a polar bond. Please pay attention to this. This is indicating that CO2 has a polar bond. We have said that before. Polar bond will actually come in place when there is an unequal sharing of electron. So there's an unequal sharing of electron because the electron will be tending to go towards oxygen. So this has a polar bond. But is this a polar molecule? Very important. Is this a polar molecule? A whole lot of students will say yes because it has a polar bond, and that is very, very wrong. Let's see. If you look at this, the attraction will be tending towards this place, okay? Because it will be tending towards the negative side because the negative side will be pulling the electron, and the attraction will be tending towards this. Look at this. Look at this. If you look at this, this is just like our normal rudiment, vector in our normal rudiment physics. This is going towards this direction. This is going towards this direction, which means here we have two partially positive because to be neutralizing this, just like carbon is attending to this, carbon is attending to this also. And because they are going in different direction, what happens? This one will neutralize it. So the two partially positive carbon will neutralize the partially negative sign, which means that the net dipole moment here will be 0. Why? Because they have neutralized themselves. Positive, the two positively charged, partially positively charged, will neutralize the two partially negatively charged, which means that the net dipole moment of this very particular compound is 0. And we have said that the net dipole moment must not be 0. There must be a kind of attraction. But looking at this compound, the attraction here has been neutralized, okay, which means it did not obey the criteria number 2, which means CO2 is a non-polar. I hope you are following. CO2 is a non-polar molecule. Why is it a non-polar molecule? Number 1, it actually passes criteria 0.89, the electronegativity difference, and that's the reason why it has a polar bond. But it is possible for a molecule to have a polar bond, yet the molecule is a non-polar molecule, and that's the reason why I had to use this. So we cannot bank alone on the electronegativity difference. It has to be the electronegativity difference and the net dipole moment. I hope we are clear. So CO2 is a non-polar molecule. Why? Because number 1, the electronegativity is greater than 0.5 mole, but the net dipole moment is 0. So it is a non-polar molecule. So CO2 is a non-polar molecule. So for you to determine the polarity of a molecule, it must actually be in accordance with these two criteria. The electronegativity difference must be greater than 0.5. Then the net dipole moment, it must have a net dipole moment. Okay, let me do this again. Let me do for H2O, which is water. Let me do for H2O, which is water, and I'll just give us a compound to try on our own to actually determine if they are polar molecules or non-polar molecules. Don't forget, HCl is a polar molecule, CO2 is a non-polar molecule. Let's see H2O. For H2O, to check the bonding, it's going to be like this. You know, the bond is going to be like this. I want us to pay maximum attention to this too, because I want to do something here so that we can get that. Don't forget that we have said the electronegativity difference of oxygen is around 3.44, okay, and the electronegativity difference for hydrogen, we have talked about that, is around 2.20, okay. So if we look at the difference, the value for oxygen is 3.44, value for hydrogen, that's the electronegativity, is 2.20. So from here we are going to have 4, we are going to have 2, okay, and here we are going to have 1. So definitely greater than 0.5. So which means it has actually passed the criteria 1, which is the electronegativity difference is greater than 0.5. And if you have not forgotten, oxygen is more electronegative than hydrogen. So oxygen tends to be partially negative, while this one tends to be partially positive. Can you see that? And that's the reason for that polar bond, which means N2O has a polar bond. And why is it having a polar bond? Because there is an unequal sharing of electron. Oxygen tends to draw the electron more to itself than nitrogen, thereby making this place to be partially negative, then this place to be partially positive. I hope you are following. And don't forget, I said the attraction will be tending towards the negative side because this one will be drawing the electron. So we have the attraction to be like this, and we have the attraction to be what? To be like this. Which means for this place now, to neutralize these two, we need two partially negative sign. So to neutralize this very particular two, you know, it's just like hydrogen is attending to this, hydrogen is still coming to this, so oxygen is attending to the two. So for these two to be neutralized, we have two partially negatively charged sign here. So which means this will neutralize this. Can we see that? Because two negative charge will neutralize 1. So it's just like we have two negatively charged and two partially negative charge, two partially positive charge. They will neutralize themselves. So a whole lot of people will now say that H2O is a non-polar molecule. That is very, very wrong. And I want to show us something here. No, because this our net dipole moment is a vector quantity. This our net dipole moment is a vector quantity. Okay. Now, what do we do? If you look at this, we have something like this, which is, if you have from our rudiment physics, if you have taken vector, you will see that this now is just like your resultant force, okay, or your resultant vector. Can we see that? And if there is a resultant vector, please pay attention to this. There must be an horizontal component and there must be a vertical component. I hope you are following. So for this, if there is this, there must be an horizontal component and there must be a vertical component. I hope you are following. If there is this, there must be an horizontal component and there must be a vertical component. I hope you are following. Don't forget, this has cancelled this now. Do we get that? This one coming to this direction and this one coming to this direction, this will cancel this. But this very particular horizontal attraction will still be attracting this very particular oxygen. Because there is these two very particular arrow is pointing upward, which means they will not attract themselves. Which means there is an attraction coming from this end to oxygen, which will make this to have an attraction and it will have a net dipole moment. I hope this is clear. Don't forget, if you have this, definitely there must be a vertical component, there must be an horizontal component, there must be a vertical component. If I have this, there must be an horizontal component, there must be a vertical component. So this is tending towards this direction, this is tending towards this direction, they cancel out themselves. But these very particular two arrows are pointing upward, which means there is a kind of attraction coming from this end to oxygen, which will make this to have a dipole moment. The dipole moment, because this and this has cancelled, doesn't mean that there will not be a dipole moment here. There's a dipole moment here coming from this very particular axis, which will make our H2O to have a net dipole moment. Definitely H2O, you have a polar moment. So our water has passed the two tests because the electronegativity difference is greater than 0.5. That's 1.24, and it has a polar. And it has a net dipole moment, which makes it to be polar. I've explained that because it's just like they are coming like this from here. Like this is the oxygen, this is the hydrogen. Can we see that now? So I have another hydrogen here, just making it clearer. Okay, so this is pointing to this. We get that now. So this will be pointing to this. This will be pointing to this. So these two negative will cancel out this, cancel out this. Don't forget, and if you have this, you must have an horizontal component, you must have a vertical component. So this will cancel this too, can you see? So we are left with these two vertical lines tending towards this oxygen, which will make it to have an attraction. Definitely for our water is a polar molecule, which means our HCl summarily is polar. Our CO2 from our example here is a polar, this one is a polar molecule, okay? CO2 is a non-polar molecule. I hope you are getting that. Why our H2O2 is a polar molecule. And how do we determine the polarity? It is by what? These two factors. The electronegativity difference must be greater than 0.5 and it must have a net dipole moment. So we can try other ones ourselves. We can try for CH4. Is it a polar molecule or non-polar molecule? We can try for SO2 ourselves. We can try for ammonia ourselves. We can try for hydrogen fluoride. A whole lot of them. You can just use this, just lay your hands on this and see. How do you know if it is polar or not polar? Using this, you can determine either they are polar or they are not polar. So, very, very important for you to determine the polarity of a molecule or a compound. It's the electronegativity difference, don't forget, must be greater than 0.5 and it must have a net dipole moment. And I think that will be all for today. And before I actually end the class for today, I said I have good news for people writing exam and I will be passing that information now. Please, if you are writing either WAEC or NECO or JAM, okay, you can use the comment section box to tell me the topic you are finding very difficult. Because I want to try to do a series on some topics you are finding difficult on this channel, teach those topics step by step, series by series, so that we'll be comfortable with them. So if you are watching this YouTube channel and there is a topic in chemistry you don't really understand, you want to take any external examination and you don't really understand those topics that are still giving you problems, please use the comment box section to tell me the topic you want me to teach, the one you don't understand, so that I can compile them. After I've seen them, I will compile them and begin to teach them on this channel. And I'm very sure after those explanations on this channel, you should get those topics very, very well. Please, if you are just watching this YouTube channel, I want you to subscribe. You can share the video, you comment, and let's keep pushing chemistry and gout forward. I love you guys. Bye for now.